I'm Stefan Kronawithleitner. I work as a network and wireless engineer at Johannes Kepler University in Austria, and I'm going to talk about interesting troubleshooting cases. I'm going to have to go pretty quick, so there will be a blog post on each of those on goodwi.fi, or just look out for me on the social medias. The overarching conclusion of this talk is get more data. If something seems off, get more data. If one issue can possibly cause a problem, maybe it's two issues, get more data. First case, student from institution X is visiting our campus and can't connect to eduroam. So if you don't know eduroam, it's basically just a tree structure of radio servers, so I'm going to look at radius logs. And looking at radius logs, I see that every user from this institution gets home server failed to respond, so there is no answer from our root server. Could be the issue with the root server, but when I look into other institutions on our campus, I see that most of them connect fine, and only this institution doesn't get an answer. So it's pretty clear, right? They have to check the radio server, they're having issues, or not. I talked to them, they said their radio server is running fine, and their CR packets, they send an answer back, but then nothing happens. So I looked more at radius logs and found some interesting stuff. We have a hospital attached to us with their own Wi-Fi, but they use our radio server, and it works for them. Okay, and in rare instances, it works on our controller too, very rare instances. So, okay, if it's not our fault because it works to other institutions, and it's not their fault because it works on the radius control of the hospital, then whose fault is it? Now it's getting interesting, right? So let's get more data. PCAP time, PCAP at the radio server. This is one that worked out. Request, challenge, until accept. That's how you should look. And this is one from our controller. So it's not that we don't get any answer. We get the initial challenge back, but then it just fizzles out and makes duplicates until it times out. So there has to be something different, right? So let's look more at the PCAP, left the 9800 from us, write the errors from the hospital, and let me highlight for you. I figured out framed MTU is 1473 on 9800 and only 1300 on AROS. Okay, that could be an issue. Putting it to test with EEP test, 1450 and above, it fails just like in the PCAP. With 1300, it worked fine. Okay, so we have 2 or 3 issues. The EEP payload is getting very large. The MTU is lower somewhere, and IP fragments get dropped somewhere. Just one of these wouldn't be the problem. It has to be all of the 3. So if I sketch this out, we have here between the AT root and institution X somewhere is a firewall, maybe IPsec, lower MTU, maybe it's in Asia. In Asia, you can have a lot of fun with out-of-order fragments. But what about their radio server? Usually radio servers ignore just the framed MTU attribute. NPS doesn't, but you can set it how you want it. But what about our controller? Why is this so high? Can we set this lower? Cisco said, yeah, sure, you can, from iOS 17.4 onwards, and we couldn't move away from 17.3. Great. So what about our radio server? Free radio is pretty flexible. I can just override whatever is coming in before proxying it out, which I did, fixing the problem. Second case, terrible connection using Zoom on Wi-Fi. Works for a while, then unusable. That's pretty broad. So let's get a first look about it. Wi-Fi status, this was a new building, had new AC Wi-Fi, Wave 2 Wi-Fi back then, planned and validated, so it was working fine. It hit multiple client types, and the log check revealed no channel changes, no unexpected roaming. It worked on wired. It was only this building on this campus. No other building had this, and it was very erratic. Sometimes you wouldn't hit it for hours. So, okay. As it is in open space, I just moved my office there for a few days and tried to see this. And I thought it was a layer 1 issue because there's a pilot factory attached to it. I thought maybe some heavy machinery. And I sat there, hit the bug, and the spectrum was clean. Okay, but I had high SNR, but dropped to MCS 0 and had no throughput for 30 seconds. So I thought, okay, let's get more data. This is not a layer 1 issue. Let's do a PCAP. And boy, did I get a PCAP. This is access point to one client, request to send. This is not filtered. This is as it was in the air. There's sometimes only 1 microsecond between these. Access point to a different client, request to send. Block egg requests. Seeing this, I thought, what is this? This does not look normal. This had to be an AP issue, and it did make sense being an AP issue because the newest building had the newest APs. The other buildings had different APs, so I looked up Cisco BugDB and found this. AP sends bursts of RTS and bar randomly, leading to low client data rates. Degradation issues with audio and video calls. Yeah, great, Cisco. So waiting for the fixed software and installing it fixed this issue too. Third case, I have installed ADROM via configuration assistant tool on macOS without issues. That sounds great. But now my home network does not work anymore. After deleting it, works again. I was, what? If it's not the cap profile is just a .mobile config file like MDM solutions make, it does not delete SSIDs or changes IP settings. So I was, what is going on? And if you look at this, there's barely anything in there. There's the CA certificate you trust, and the SSID name and security settings, right? Wait, what's that? Proxy type auto? What's doing that in there? Sadly, it's allowed in ADROM to have a WPAD proxy server. And so this is in the profile inside. And what happens is macOS queries just WPD in the search domain. And somehow at home at this student, this gets intercepted. And instead of an answer or an Unix domain, he gets a timeout. And when macOS receives a timeout on this, after the 2 seconds for the timeout, it shuts down the network. And I've never seen this before. I have a Mac myself. We have thousands of MacBooks on our campus. So I tried this out, and if you have WPD somewhere in the query string, no matter to which server, no matter to which domain, or if it's just by accident is somewhere in the domain name, you get a timeout and the network shuts down. So what intercepts? I found that Google Nest Wi-Fi sometimes does this. In our case, it was some Aries cable modem. I talked to the provider. I don't know why this is happening. I didn't get further than first level support, but they are intercepting it, and you get a timeout. So the solution was I made a profile by hand for this one user with proxy setup set to none, so that his network at home works, and yeah, fixing the problem. Fourth case, Wi-Fi is weaker now, getting fewer bars, lower throughput on my MacBook Pro, dropping out of Wi-Fi often. Again, pretty broad. So first look, it was a MacBook Pro 2018. That's a pretty good client. And signal SNR was more than 10 dB less than usual. That's a lot. And doing a lot of traffic right next to it dumped the SNR. So if I took my iPhone, did a speed test in 1 meter, it kicked the notebook out of the Wi-Fi. So, okay, that's weird. So I looked more at the stats, and I noticed it consistently did only 2 spatial stream connections to a 4 spatial stream IP. Now, if you know the MacBook Pro Intel ones, they are one of the few 3 spatial stream clients. So even with a relatively high SNR, only doing 2 spatial streams, that looked odd. So I thought maybe this is a hardware issue. So I decided to open it up. Looks good, right? And anyone spotting an issue? Let's zoom in a bit. The antenna cable shook loose, even touching the metal casing, and this caused all of the issues. So even your known good clients can fail sometimes. So yeah, get more data. Thank you.